Alright, hello everyone. So this is the recap video for M1 topic 2 kinematics of motion in straight lines. So we are going to do a revision on the content that we have learned throughout this chapter. So yeah, before we move on, right? So yeah, just to note that the words kinematic here, meaning that we are only focused in the motion of the particle. So we are not taking into consideration of what causing the motion. So for that, we are going to look at, we only will look at it when we talk about force in future. Okay, and the motions that we are looking at, right, is all in a straight line. So which means that we will have a direction of, if let's say to the right hand side is the positive one, then to the left hand side it will be a negative one, or up or down. Okay, so basically that's the idea. The motion will be a straight line. All right, so now when we talk about the introduction of this topic, we talk about few basic concepts that you need to know, right? So first one is that we have distance, okay? And the other one for distance is the displacement. So for distance, we mentioned that it is a scalar quantity. So it actually tells us how far the particle has traveled. Whereas for displacement, it's a vector quantity. So it didn't actually state how far the particle has traveled, but it gives us the position of the particle relative to the origin or the initial position that you set as the initial point. Okay, so that's a difference. Then we also learn the two quantity to measure how fast the particle is moving, right? So the first one is speed. Okay, so speed is in relative to distance. All right, so it tells us that how much distance a particle move in a certain time, and then for velocity, then it will be the rate of change for the displacement over time. All right. So the difference between these two quantities is that for speed, it is always a positive one because it's like how far the object travel then divided by the time. But for velocity itself, it can be a positive and negative, depends on where is the direction the object is moving towards, right? Because if it is having a positive displacement, then you are going to get a positive velocity. So which means that the object is moving towards the positive direction so that you can only get a positive displacement, right? So the same thing, if you are moving towards the negative, then you have negative displacement as well as the negative velocity. Then the last one, we have the acceleration. So basically, acceleration tells us that how fast the velocity change according to the time. Okay, and bear in mind that for negative acceleration, it doesn't always mean that the velocity is decreasing. It also can be causing by the direction itself. So you need to put into the context of the questions and you try to understand from it. Okay, then other than that, we have like three important idea for this tree is that if let's say you are finding the average speed, right? Average speed lap, right? So make sure that you are taking the total of the distance and then you divide by the total time that you are using. So this is very important when we try to look at the VT graph later. So make sure that if let's say the question is asking average speed, make sure that you are calculating the total distance but not the total but not the net change in the displacement only. So for the average velocity, then it will be the displacement, right? But displacement, we talk about the change in position. So that's why we try to find what is the velocity in. So let me try to use S here, okay? So yeah, so which means that we will need to find what's the displacement at the initial point and what's the displacement in the end point. Then we try to compare it, then we divide by the total time because we only want to find how fast does it change? I mean, I don't care about how long time. I mean, how much it move in total. But what I'm looking at is the end result only when I try to talk about average velocity for the whole time. Then after that, for average acceleration, okay, so the same thing is going to be the net change in v, the net change in velocity, and then divide by the total time. All right, so that's it for the introduction part. So now we'll be looking at the ST graph and the VT graph. Alright, so this is a displacement time graph. So basically, displacement time graph tells us that what is the change of position of the particle with respect to the time, right? So that's why we have the displacement versus the time. Okay, so now when we try to dash information, so rather than the displacement with respective to the time, another information that we can always get from the ST graph is the gradient, right? So the gradient here actually represent the velocity because it's basically the displacement over the time, right? So this is how we normally calculate the velocity as well. Okay, so when we try to go through the example graph that we have here, right? So we can see that the AB is a straight line. So which means that at all the point here, you will have a constant gradient. So by having a constant gradient, we know that there's a constant velocity here as well. Okay, and because of you can see that it starts from here, then it reaches certain point here. So that's why the displacement is actually increasing towards a positive direction. So that's why it's moving towards a positive direction. Okay, then what happened for BC? So for BC, you can see that there's no change in terms of the displacement over the time. Am I right? So that's why it is actually having a constant S. So constant S meaning that there's no change in the displacement. In another words, you can see that the gradient here will be zero as well. So that's why the V is actually zero, which means that the particle is actually at rest. Okay, so yeah, it doesn't move at all. I'm sorry, at rest. Okay. All right. Then after that, the third one, we have the particle, we have the CD here. So we can see that for from C to D, so comparing to the AB, which is a straight line, CD here is basically a curve. So you can see that if I were to compare the gradient here and the gradient here, definitely the gradient at the front here, at the first part, is going to be much more larger than here. So which means that we can see that what happened here is that the gradient actually decreasing. So if let's say the gradient is decreasing, meaning that it has a decreasing velocity, right? So as you compare to here, meaning within a short time, it actually moved this much of the displacement. But within this time interval, it only moved like this little displacement. Okay, so that's the idea for decreasing velocity. And you can see that this particle is actually moving towards a negative direction. So from this number, perhaps this is like a 10. So from 10, it moves to 0. Then after that, it moves to negative. So that's why it is moving with a decreasing velocity and is towards the negative direction. So if we were to draw a path diagram, so which means the particle will eventually look like this. It moved towards the negative, and after that it stopped here for some time. Okay, then after that it moves, so it go back to the origin here, right? Oops, I'm sorry, I think I made a mistake here. Okay, so this particle isn't start from the initial point, so that's why it might be somewhere here. Okay, so it moved towards the positive direction. Then after that, it take a rest here. Okay, then after that, what happened is it moves and it come back to the origin. Then after that, moves towards the negative. So this is like the whole path diagram looks like. Okay, so now let's try to look at the other graph, which is the VT graph. All right, so this is for velocity time graph. So the difference between the velocity time graph and the displacement time graph is that velocity time graph shows the motion, okay, the motion of the particle with respect to the time, right? So meaning that where is it moving towards? Is it towards a positive direction or the negative direction? And then what's the and then how fast is that moving? Okay, so please be remember that having a velocity in a positive, so meaning in the area of the positive x-axis doesn't mean that the particle is at the positive displacement. It basically just means that the particle is moving towards a positive direction. Okay, because this is a velocity time graph. So for the displacement part, then we'll need to look at the area under the graph already. Okay. So the same thing, the information that we can try to extract from the graph is the gradient. So the gradient here is the velocity over the time. So that's why it will give us the acceleration. All right, so same thing, let's try to look at the movement here. So which means you can see that it's exactly the same graph, but how are we going to read this graph will definitely be different because of the type of the graph here. Okay, so from A to B, you can see that the gradient is the same. So that's why they are having a constant acceleration. Okay, so throughout this motion also you can see that no matter it's here or here, the velocity is all positive. That's why this particle is actually moving towards a positive direction and with a faster and faster rate. Okay, so that's the idea because you can see, for example, if let's say this is 5, this is 20. So the object is actually moving faster in a positive direction. Okay, then after that, for the second one for BC, so we can see that there's no change in the velocity, right? So for this one is the constant velocity. Okay, so constant velocity meaning that the speed is basically the same lah. Okay, same speed. All right, so now let's try to look at the part for C to D. So the part of C to D, you can see that the gradient is actually decreasing as well. So that's why in this case, it tells us that it's going to be a decrease in the acceleration. Okay, so this is, you can see that when you try to compare C and D, right? So from C, perhaps you can try to add in here from C to E, this part, the particle is still moving to the positive direction. It's just that the velocity is getting lesser and lesser. But for this point, you can see that the velocity is increasing, meaning it's moving faster and faster, but towards a negative direction. Okay, so I hope that you can see this. So for this part, the velocity decrease, but then it's still a positive direction. So for this part, the velocity is actually increasing because the magnitude is increasing, right? But then it moves towards the negative direction. Okay, so in total, when you try to look at this graph, then it will be a decreasing acceleration lah. Yeah. Okay, so and then the other thing that we can try to read from the graph is the area under the line, right? So the area under the graph can actually tell us what's the displacement because if velocity is equal to displacement divided by the time, which means that the displacement can be found out by using by using velocity multiply the time. So the area under the graph can tell us about the displacement. So from here then, which means that we can see that when the particle move from A to B, the displacement of the particle is a positive one, right? Even it moves until C, it also is a positive one. Then until it moves to E, then it's having a positive velocity. But after E, right, you can see that the area under the positive x-axis here, it will form a negative displacement. So that's why you know that the particle now is still okay. Do you think that it still is already at negative? Okay, it doesn't mean so because when you try to find the displacement, if let's say we are talking about from A, if let's say you are comparing the point E to point D, then obviously the displacement is a negative one lah, because this is the initial point, right? Then after that from here, then the area that you can form is basically just under. But if let's say we try to compare A to D, then maybe the particle is most likely still at the positive side because you have so much of positive displacement, but as you try to move a bit to the negative part, but it's still not enough for you to reach the origin yet. Okay, so that's the idea for area under the graph. So basically looking at what interval that you need when you try to find the displacement that you need. Okay, so that's the part. Then after that, we'll be looking at the formula, so which we talk about the constant acceleration and also the variable acceleration. All right, so we know that for all the cases where we involve constant acceleration, there are actually four Suvat formula that we can use. Okay, so we can try to ignore the one that with Vt minus because that's not going to be given in your exam. All right, So for your constant acceleration, we have four formulas. So I hope that you can roughly remember it, or basically you can just find it in the formula sheet that will be given. So S will be equal to 1 over 2u plus v over t. The other one will be S also. S will be equal to ut plus 1 over 2at squared. The last one is the square thing. So v square is equal to u square plus 2as. All right, basically you know how to use it now. So all these four formula will relate four so all this formula will relate four components from U S U V A T. So basically depends on the questions and what is given and what you want to find, then you decide which formula that you are going to use. Okay, then for vertical motion, there's something called as the gravitational acceleration, which you must remember for all the object that experiencing a free fall, they will have a gravitational acceleration of 10 meter per second square. Okay, then the last part of the lesson, we talk about the variable acceleration, right? Which we mentioned the differentiation, the integration. This is how we relate our displacement function, our velocity function, and the acceleration function. So from displacement to velocity, we do differentiation. From velocity to acceleration, we do another differentiation. I'm sorry, this is A equal to dv dt. Okay, so the other way around, then for us to get v from A, then we will need to do integration. So A dt. So same thing. So please make sure that if you are finding the expression, so you will need to have one information so that you can find what is the constant that you get when you carry out your integration. Okay, so for the part when we try to do the differentiation, right, it actually helps us to find what is the maximum. Yeah, so this is a thing that I have mentioned about the correction in your team also. I hope that you check the message. So yeah, that's a minor mistake in my previous lecture that there's no difference between maximum and minimum in terms of the velocity and the displacement. But I think for displacement, it's not that much because I mean, for minimum displacement, then if let's say you use the smallest number to represent, it's kind of awkward as well. So that's why when you try to look at the questions, most likely they will have maximum displacement rather than the minimum displacement. Yeah, because no matter it's positive or negative, that's the maximum displacement that you have, right? Yeah. But the idea is for you to get the maximum point or the minimum point, then you will just do the derivative is basically equals to zero lah, equals to v equals to zero. Okay, so similar for the velocity as well, but for velocity, maybe minimum is still possible because you might have a negative number for velocity and that's the minimum. So the dv dt or the acceleration is basically equals to zero. So for the part for integration, if let's say you are given a time interval, you can always try to find your displacement by substituting the time interval as the upper limit and the lower limit so that you can straight away find your answer. So similar to velocity as well. Okay, so the only thing to note here is that when you try to find the displacement here, right, it's very important that for distance, you will have another case, which means that you can always try to use T1, T2 as well. But the problem is that you need to make sure whether there's a change of direction involved or not. Okay, so it's either like this, or if let's say it involve a positive and a negative direction, so which means you might need to split it. So perhaps you will have t1, t2, v dt. Then after that, you will have the other one, which is maybe from t2 to t3. Okay, so that's the idea. So it's very important for you to check the change in direction so that you can find the total distance without eliminate any total path that the particle actually travel, but is like excluded by the displacement. Okay, but if let's say you are finding the displacement, then there's no problem at all. Alright, so that's the part for these topics. So yeah, we'll have our first test after we finish the next chapter. So you can start to do your revision and so that's it for the revision. Thank you.